signal. It will be like yesterday in the lab also we have done. Yesterday in the lab also we have done. The waveform will be something like this. This is the outer, okay, and inside this high frequency sine wave we have to draw. Okay, now dotted line is not the output, that is outer of the output waveform. Okay, now this drawing what I am doing now, this is the output waveform. This is the output waveform. Okay, high frequency carrier will come. This is the modulated signal S of t. In lab also we have done it. This is S of t. And from here, the maximum and minimum. Okay, so here is the center line. On the positive side, you take the maximum. This is V max. And minimum height, this is V minimum. Modulation index is nothing but V max minus V min divided by V max plus V min. V max plus V min. Okay. Now the peak amplitude of the AM signal, amplitude modulated signal means S of t. Amplitude modulated signal means S of t. It varies from 2 volts to 10 volts. Okay, 10 volts is the V max and 2 volts is the V min. 10 volts is the V max, 2 volts is the V min. And now we will take it as 10 minus 2 divided by 10 plus 2, which is 8 by 12 or 2 by 3 or 0.67 is the value. Okay, so 0.67 is the value for modulation index. 0.67 is the value for modulation index. Okay, now calculate the carrier power. Calculate the carrier power. Okay, and here we have one more thing which we can take it as V max. We have another formula. V max we have another formula. It is AC into 1 plus mu. Okay, V min means AC into 1 minus mu. AC is carrier amplitude. AC is carrier amplitude. This maximum height is also other way. AC into 1 plus mu. This minimum height is other way. AC into 1 minus mu. Okay, V max, V min. Now, from the first equation, V max, okay, from the first equation, what I will do, V max value given in the question as 10. V max value given in the question as 10. AC we don't know. Mu value we calculated 2 by 3. Mu value we calculated 2 by 3. Okay. So I will substitute that. And then AC calculation, it is 10 divided by 1 plus 2 by 3. And I will not use this. Okay, any one equation you use, you will get AC value. So 10 divided by 5 by 3. And cancel, numerator will have 2 into 3, which is 6 volts is the height of AC carrier amplitude. AC is nothing but carrier amplitude. Okay, carrier signal amplitude. Okay. Now I will go with carrier power. We know AC square by 2 is the formula. It is 6 square by 2. 36 by 2 is 18 watts. 18 watts. Next, sideband power. Okay, we can also take sideband power is nothing but from this equation you can see, from equation 1a you can see total power is nothing but carrier power plus sideband power. Okay, so carrier power, sideband power can be written as PC into mu square by 2. This is very easy to remember. You can see in equation 1a. Second term, I can write it as PC into mu square by 2. Second term, I can write PC into mu square by 2. That is sideband power. Okay. You need not remember big formulas. Sideband power is nothing but PC into mu square by 2. From equation 1a, I am getting this. Okay. Now, substitute, already carrier power 18. Mu value is 2 by 3. Okay, for simplification, I am maintaining 2 by 3. If you write 0.67, that multiplication, everything will be big. Okay, and divided by 2. Now, cancel this 18 and 2, it will become 9 into 4 by 9. 9 and 9 will get cancelled. So this is 4 watts, which is sideband power. Next, I have total power. Total power is nothing but carrier power plus sideband power. So it is 18 plus 4, which is 22 watts, which is 22 watts. Okay. So I completed calculating modulation index, which is 2 by 3. Then calculating carrier power, which is 18 watts. Then sideband power 4 watts. Total power 18 plus 4, which is 22 watts. Okay. AM signal radiates, AM transmitter radiates 50 watts, and the carrier is modulated by a sinusoidal signal. The modulation index is 0.707. Determine the modulation efficiency, carrier power, sideband power. This is A question. B part, determine the peak amplitude of the carrier before modulation and after modulation. Now coming to AM radiates 50 watts. This is the total power, PT, total power. And the carrier is modulated by a sinusoidal signal. Modulation index is 0.707. This is mu value. So coming to the solution, total power, which is PC into 1 plus mu square by 2. Okay, PC into 1 plus mu square by 2. It is given as 50 watts. It is given as 50 watts. And the PC value we can find, mu value also given 0.707, which is 1 by root 2. 1 by root 2. Now this is 1 plus mu square by 2, which is 50. I will substitute the mu value 1 by root 2 whole square and divided by 2 equal to 50. Now what is PC value? We will have 1 plus 1 by 2 divided by 2 will become 1 by 4, 50. And then PC value is, this is 5 by 4, PC into 5 by 4, okay, equal to 50. And now PC value equal to 50 into 4 by 5, cancellation with 10, it is carrier power 40 watts. Carrier power 40 watts. Okay. So what they are asking, first one is modulation efficiency, neta, carrier power, PC, sideband power, PSB. Now we have completed carrier power. Now PSB sideband power is nothing but PC into mu square by 2, PC into mu square by 2, because this total power is nothing but carrier power plus sideband power. That is this formula, PC into 1 plus mu square by 2. So first term PC, second term PC into mu square by 2, that is the sideband power. And now PC already we got 40, mu is 1 by root 2 whole square divided by 2. So if we simplify 40 into 1 by 4 and cancellation 10 watts, sideband power, it is 10 watts. Okay. So this is carrier power, this is carrier power, and this is sideband power. Sideband power. Okay. So two things we completed. Carrier power, sideband power. Now coming to efficiency. Neta is nothing but mu square by 2 plus mu square is the formula. Mu value, it is 1 by root 2 whole square divided by 2 plus 1 by root 2 whole square. Now if you simplify, this is 1 by 2 divided by 2 plus 1 by 2. Make LCM 1 by 2. This is 5 by 2. 2 will get cancelled. 1 by 5, which is 0.2. It is a constant. Neta is a constant, no unit. So 0.2 is the answer, absolute value. If we want in percentage, we have to multiply with 100. 0.2 into 100 will become 20%. 0.2 into 100 will become 20%. Okay, this is absolute value. If we want neta value in percentage, it is 0.2 into 100, which will become 20%. But by this, so A part question solution completed. From here, it is A part solution. Now I am going to B part solution. I am going to part B. Part B, you can see determine the peak amplitude of carrier before modulation and after modulation. So carrier amplitude before modulation. carrier amplitude before modulation is AC. Carrier amplitude before modulation is AC. And carrier power is nothing but AC square by 2. We calculated carrier power over here 40 watts. Okay. So 40 is nothing but AC square by 2. AC square by 2. And 80 is nothing but AC square, and AC value equal to square root 80, and voltage is the units. Voltage is the units. This is before modulation. So carrier power after modulation means we have the diagram like this. We have the diagram like this. This is the maximum. Okay. So this is AC into 1 plus mu. 1 plus mu. This is the V minimum. This is V maximum AC into 1 plus mu. This is V minimum, which is AC into 1 minus mu. These are the things after modulation. So after modulation, the carrier power maximum and minimum. Maximum and minimum. Okay. Now we will have after modulation. After modulation. After modulation. Carrier amplitude is AC into 1 plus mu. So AC just now we got root 80. 1 plus mu is 1 by root 2. You simplify and find what is the answer. And similarly AC into 1 minus mu. V max, V min. V max, V min, which is root 80. 1 minus 1 by root 2. Find the answer. Okay. So I am leaving some calculations to you. I am leaving some calculations to you. You can just see what is the question mark value. You can just check and check and verify what is the. This is V maximum and this is V minimum. That is carrier amplitude after modulation.